So I hope you're as excited as I am because we'll be talking about how you can make real impact with large language model integration. Now, what does that mean in practice? Well, I want to walk you through how you can create a large language feature for your organization, the business that you work for, that actually does something useful, right? So not just a technology experiment, but something that you can actually use in production. And to talk you through that, I'll be giving you a case study on Copilot and GitHub support, which is one of the features that my team owns. But before we head into that, a little bit about me. I'm Zen, I'm a software engineer at GitHub, and I'm part of the customer success engineering team. Now, this is a team responsible for customer success, which entails a lot of different things. However, I think the focus for today should be on understanding what we're trying to do with self-help. So self-help is this concept in our team where if a customer has a question or a problem with GitHub, then they should be able to solve this problem themselves. And they can do this by us providing the right resources to help them, but also with our smart automations. And you'll see examples of that because, right, this Copilot and GitHub support solution is one example of just that. Now, first, I want to give you a bit of a walkthrough around the GitHub support portal. This is one of the platforms that our team owns. It's the most important one to just conceptually understand for today. And the GitHub support portal is where a lot of customers go to when they need human intervention for a problem that they have on the GitHub platform. A lot of customers also land here if they have a general product question or something that they're stuck with that they think they cannot find an answer to when they, for example, go to our documentation. And in the end, what we see here is a very typical contact form where you as a customer are able to ask a question and create a support ticket, right? Very typical. Our support engineers will be ready to answer a question at this moment, but of course that is a lengthy process. So before customers land on this page, they are able to use a lot of our self-help resources. For example, we have a virtual assistant, and this virtual assistant will walk you step by step through specific troubleshooting steps if you, for example, have issues with multi-factor authentication, right? So we identify the top issues that our customers have, and we either, of course, fix it in a platform, or we provide this troubleshooting guide if it's something that might be misconfigured. That being said, I want to delve a little bit deeper into business context here. And it's because while I will be sharing a lot of technical details today, I also want to focus a lot on what we're trying to do with this Copilot solution from the business side of things, because that's what makes a lot of sense to us when we're trying to focus on creating a useful feature, right? So on the support portal, we have hundreds of support tickets that get created daily. And this, of course, increases as GitHub gets adopted by more and more customers. And these tickets all have varied complexity. Some people just have general product questions, right? While others really have issues with their GitHub server deployment, for example, and they need some humans to help them out. Now, one of our goals is to resolve simpler support issues before ticket creation, because we have our support engineers that look into the tickets that do get created. And these are professional subject matter experts. They know pretty much everything about GitHub. And of course, because of their expertise, we have the most value from them if they solve the most complex topics. So that's why we're trying to automate those simpler support issues. And we're not trying to automate the job of a support engineer because that's impossible. There's simply a lot of tickets that are complex and require that human intervention and expertise. However, we want to resolve those simpler support issues so that all of the support engineers can focus on the most complex topics. Because don't worry about the amount of work that's out there. As I said before, those support tickets get created, more and more as GitHub gets adopted. So the support engineers will, always have a lot to do. Don't worry about that. Now, as I gave a bit of a preview on the name of our solution, Copilot and GitHub support, I want to make sure that we're all on the same line as to what GitHub Copilot actually is, because I'm not going to make any assumptions that everyone is familiar with it, right? So GitHub Copilot essentially used to just be a code completion engine that you could run in your code editor. And therefore, you could use a large language model to help code with you, right? It could complete code for you. It could give you recommendations. And nowadays, it's actually much more than that. So recently, GitHub actually introduced GitHub Copilot chat in both your editor and on the GitHub website, which allows you to actually have conversations about coding best practices, right? Or even chat about your repository. And you can also use GitHub Copilot in your pull requests nowadays to, for example, generate a summary of the code changes that you published. So GitHub Copilot is much more than the previous extension that it was before. And of course, this concept of Copilots in general is taken even further by Microsoft, who have implemented Copilot solutions in their own suite of products, right? So all in all, GitHub Copilot is bigger than it's ever been. And that's also why we've built Copilot and GitHub support. And to give you an idea of how this feature works, I want you to imagine that you're a GitHub administrator and you have onboarded all of your developers to GitHub and you've enabled single sign-on. Now, in GitHub, single sign-on works a little bit differently than you might be used to on other platforms, because within GitHub, you have to log into your personal scope first with, for example, your username and password, and then you can see your own code in your own projects. However, if you want to access the code of your organization, you kind of have to log in again if single sign-on is enabled. Effectively, there's 2 layers of authentication there, right? Now, there are a lot of other platforms that offer a single layer of single sign-on. So let's imagine that as an administrator, you're confused about that and you understand that it works, but you want to understand why it works the way that it does. And to figure that out, you might use web search, you might browse through our GitHub documentation, but believe me, there's a lot of customers that land on the support portal. So we also want to provide those customers with an answer. And this is actually a real support case that a customer was able to solve with our Copilot and GitHub support feature. And to illustrate that, I can show you what the feature looks like in this video. It might be difficult to watch for those in the back, but I'll give you an audio description of pretty much everything that's going on. So no worries there. Let's actually first make it a bit bigger. And I just want to first go back to the start of the video. So here you can see once again, I'm filling out that ticket form, basically with the issue that I was talking about before. So I really just want to understand GitHub single sign-on. And I get the option to either create a ticket directly or chat with Copilot. And remember, it's optional, right? So you're able to just create a ticket if you want to, but you've had good experiences coding with Copilot. So you figure, let's give this chat a shot, right? Now watch this. If you select chat with Copilot and you click on start chat, the chat will actually start immediately and an answer will be immediately generated for you. And this is an important design principle that I'll come back to later. Now what you see here is it's going to give you a pretty extensive answer. And it comes down to what I said before, right? How we kind of have this 2-layered approach to authentication when it comes to single sign-on in GitHub. The most important thing to understand here is that this answer is based on the references that you see below here. And we're basically embedding those resources so that they can be injected and searched for when we're actually querying the GPT model later on. Now, in this case, I always have the option to still create a support ticket or continue chatting. So here you see that I have many options as a customer. However, if I'm satisfied with the answer, I can tell us that the problem is solved. And then I will get some celebratory, well-deserved confetti. So that's nice. So that makes you feel happy, right? So that's great because we're happy because we were able to instantly resolve your problem. And of course, you're happy because you got an immediate answer to your question instead of having to create a support ticket and having to wait potentially a couple of days because there's a lot of support tickets out there. Just going to make this small and probably have to actually continue the slideshow again. So we've been going for a while. However, I want you to know that you're really going to get something out of this. So to answer the question, what will you learn? I actually need to know a little bit more about the audience. So can I please get a raise of hands for those who have already implemented a large language model feature for their organization? It's cool, I see it. Yeah, half. That's an interesting answer, right? So I really want to walk you through getting to production there. And I see some other hands raised. I want to talk with you, during pizza time after the talk for sure, because I'm sure we can learn a lot from each other. And those who have not raised their hands will probably learn the most here because we'll walk you through the process of developing and deploying this all the way from the early alpha stage to production. Let's have a look at how we will approach that. So this is kind of our playground for today. This is our entire project roadmap for the project Copilot and GitHub support. And it goes back all the way to March of 2023. And it goes on and on and on to the present day and even the future. That's how beautiful technology is. We can travel through time. And there's a very good reason why this project started in March of 2023. Is there any like ChatGPT enthusiast here that can maybe, tell me why March 2023 is so important?
Wasn't the GPT-4 released?
Well, partially, I think that's one of the things. That's a really good one that we actually wanted to cover for as well. And in addition to that, you can also call it with the API, right?
Yeah.
So I think GPT-4 was also released around the time, right? So yeah, it's kind of both at the same time, really. And so during this envision phase, we asked ourselves, what can we achieve with large language models in general? The reason why we asked ourselves this question was because the OpenAI Chat API, probably around the time of the GPT-4 release as well, was released. And this caused a lot of organizations to start experimenting. Now, I have to say, usually I'm more of a fan of solving a problem and then having a look at what technology can solve the problem. However, here it was often the opposite. Companies would use a technology and just experiment with it without actually solving a problem. Now, I don't want to say that's a bad thing. If you, for example, have a hackathon that just explores a new technology, that can be very, very positive, right? However, you shouldn't be stuck in that mindset for the upcoming next year. You should eventually try to match that to an actual business use case. That being said, we also had the same approach where we were just playing around with the Chat API because it had so many promises. And one of the things we did during an initial brainstorm is add a Copilot interface within our ticketing system. So in this case, we're using Zendesk. And this would be support engineer facing and not customer facing. So it would, for example, help our support engineers to craft more detailed responses to the customer or try to reformulate their answer in a different way, basically trying to help them in that regard. In the end, though, we decided on a customer-facing approach, and there's a multitude of reasons for this. However, two are the most important. First of all, we wanted to ensure that we can measure the success of the solution. Unfortunately, having a support engineer-facing solution, especially one that allows you to craft answers, well, it's nice, but it's difficult to measure success. There's a couple of things that you could come up with, but it's really difficult to map to a proven business issue. However, the customer-facing approach of putting this Copilot interface close to the customer focused on a real validated business need, specifically all those support cases that get created every day, right? And this business need is not going to disappear, it's just going to get worse as GitHub gets more adopted. So we know this is a business need that we need to meet, and that's why we went for the customer-facing approach. So we're slowly moving forwards in the timeline here, and we're kind of in the middle of thinking about what do we want to do and actually executing on a first alpha release. So we're kind of developing our first solution. And to walk you through that, I want to answer the question, how do we implement an intuitive feature? There's two parts to this. First of all, we have the concept of the solution. And one key element here is that customers don't have to understand how to interact with a large language model. With all due respect, one mistake that I see in a lot of large language model implementations is that a chat interface is just slapped on an existing solution, and it just opens with the customer with the programmer having the expectation that the customer fully understands how to interact with a large language model. This can work in ChatGPT, for example, because it's meant to be free form. However, in the case of trying to support or trying to solve a support ticket, it's difficult to let customers actually ask the large language model the right questions. So instead of having this open-ended chat, we're actually leveraging an interface that our customers are already familiar with. In this case, the ticket creation form. All you have to do is fill in that ticket subject and the ticket content, which many customers have already been doing for years. And then when you press start chat, we are the ones that create and craft that first message for you that we send to the large language model, injecting it with the right context and adding nuanced information into it if necessary. And so, of course, after that, you can continue to chat however you like. But crucially, that first interaction is something that's hands-off. You just have to press start chat. Secondly, we have respect for ticket creation fallback and the time of our customers. If you've been thinking throughout this presentation, man, this is like another typical support chatbot. I don't blame you because there's a lot of frustrating experiences that I've had on other support portals where a bunch of chatbots are being put in front of the ability to just create a ticket. And, yeah, that might work from their perspective because they're blocking tickets from being created, but it's just going to make you feel frustrated, right? So I want you to understand one more time that this is just an optional feature and you can opt out of it, by default. And even if you do go into the chat, even if the first answer hasn't been fully generated, you can just click on the create a ticket button. So we do really respect that option. And so it will always be available. So the second part is the model. We're using Azure OpenAI for this specific feature. Now, of course, some of you may be aware that Copilot, the original feature, GitHub Copilot, is using the Codex model, which is really trained on a bunch of code. In this case, we kind of started with a clean slate in the sense we started with the plain GPT-4 model. And that's because this is a totally different use case, right? And so GitHub Copilot as a broader service is relying on a multitude of large language models, not just that original Codex model. In fact, for this solution so far, we have not fine-tuned or trained the underlying GPT model at all. What we're doing is we are injecting our GitHub documentation as a source of truth. So we're selecting the most relevant pieces of GitHub documentation and injecting that into the prompt. It's a very standard approach. Now, this approach might not work for everyone because what it requires is really high quality data. And in our case, our documentation is not an afterthought. We have an entire team of full-time employees who keep this documentation up to date, and they're always, ready to create new documentation for all the features that are released on the GitHub platform. So in our case, we didn't have to search through an internal knowledge base to find high quality data to feed to the solution. We already have the GitHub documentation. That being said, we did consider, for example, fine-tuning the model on ticket data because we have a lot of tickets in the past. But we found a lot of issues when it comes to PII, so personal identifiable information. Sure, you can remove the names of companies in these support tickets, but often the tickets contain diagnostic information and other, identifiable information. So it's just not great. And we also considered fine-tuning on GitHub Communities data. And GitHub Community is basically an open discussion board where any customer can ask any question and get answers. However, that data is not vetted for quality. Other customers can mark the data as useful, but that doesn't mean that the answers were actually correct, right? So we really found that GitHub documentation was our best source of truth that we could pick out. And so the model simply relies on, us injecting the right documentation. So cool, right? We're getting closer and closer to the alpha release. We have a functioning feature. However, we're not just going to release it to customers without considering what happens in this case, right? So even though we do want to ship fast, what did take a few months, we do have this feeling of, hey, we want to ship to learn, right? However, when we release the alpha version, we're asking ourselves the question, how do we safely onboard customers? Especially because this is a more risky AI feature, we want to make sure that the solution is at least ready to be rolled out to a certain set of customers. I'm not going to give you a rundown on all of GitHub's plans. Don't worry, that's going to take all evening probably. But I do want to explain that we initially started out by rolling out the solution to GitHub Enterprise Cloud customers. And these are customers that essentially run github.com, so the web version, and they're usually larger organizations, hence the Enterprise Cloud name. And this means that they're serious customers. So we're not exposing this model to unauthorized users that we don't recognize. We know that the initial usage will be quite serious. And this is important because we first want to make sure that this solution actually satisfies our business needs. And all of the abuse that unauthenticated users might bring to the model are kind of distracting us from that. But no worries, we will actually deal with them later on. For now, though, we will just release to Enterprise Cloud customers. That's not without risk, though, because they are paying customers. So how do we guarantee that we can still safely onboard them? Well, this is where the red team testing approach comes into play. And very simply put, when you red team test a large language model, you have a group of experts that query the model with challenging use cases and verify whether the output of the model is factually correct. And here, once again, we have great internal resources, namely our support engineers, because they are the expert testers on both the input side as well as the output side. Let me explain that. So on the input side of things, support engineers have probably seen hundreds, if not maybe even a few thousand support tickets. So they know what the challenging support cases are. In addition, they're experts on the output side because they've written many support answers in the past, right? So they're able to both challenge the model with very difficult support questions, and they can verify whether the output is correct. Now, our support engineers are not able to cover everything that you can ask with natural language. And that will always be a difficulty when you're testing a large language model, but it definitely comes close enough to be able to release an alpha. To give you an idea of what this red team test actually resulted in, I want to talk to you about two remediations that we applied to improve the performance of the model and to comply with certain best practices that we wanted to put forward. So on the left, you can see that a user asked if GitHub Pages, one of our features, could be used as a content delivery network. If you're not familiar with a content delivery network, the main point to understand is that it implies that you're going to use a lot of network bandwidth, right? Now, the initial version of our Copilot did not respond like this. It did not say that it's not intended to be used. It actually said, yeah, sure, you can use GitHub Pages like this. And the reason for that is because the documentation doesn't necessarily tell you that it's a problem. However, our terms of service definitely tell you that we have bandwidth limitations, right? And we did not include the terms of service in our initial approach. And then we realized, hey, this is a bit of very important legal context. And now with every query, we include the most relevant bit of terms of service content as another source. This gives the model a bit of legal context. It's not going to cover everything, of course, but it will help us with these kinds of questions. Now, secondly, as I said before, because this is a natural language interface, you can ask questions about anything. And to be honest, we know that the model's not going to be correct all the time. Hallucinations, so basically, made up facts, are quite common with these large language models. However, some made up facts are a bit more problematic than others. Let's say that the model responds with incorrect troubleshooting steps. Well, the customer can just create a ticket, right? However, let's say that the customer is asking about the purchase of licenses and the model suddenly says that they somehow have a discount that doesn't exist or that they are eligible for some kind of special plan. That can be a little bit more problematic to deal with from GitHub side of things. So what we're actually doing is we are blocking certain topics from being talked about by Copilot. And the way that we do this is we basically match the ticket content with, of course, the most relevant documentation. And we've put certain documentation, which indicates topics like billing into a blocked topics list. So if one of those topics is actually raised as one of the top 3 documentations for the support ticket, then you will not be able to chat with Copilot, and you will actually have to create a ticket instead. So this kind of guards GitHub, but also the customer from certain wrong answers that we aren't very confident we can answer correctly all the time. Super cool stuff. So we actually developed this alpha version and we got it out to our first set of customers, right? Very nice. Now, let's say that we want to move on immediately to the beta phase. Well, we didn't really want to do that. Why not? As I said before, for us, it's important to validate that the solution is actually doing something useful. And so it's maybe not the most exciting thing for tech enthusiasts, but we decided to go for a business evaluation around the September mark. And what does that mean? Well, we really wanted to see if the feature helps the business. And to do that, we have 2 main success metrics. First of all, we have whether the ticket was deflected after an interaction with Copilot. This means that if you interacted with the chat and you quit the page, that would count as a ticket deflection. Now, we don't see that as a universal win because it could be that the Copilot answer was so terrible that the administrator or developer is just really frustrated with GitHub and just doesn't want to deal with it anymore and just closes their laptop. Yeah, sure, we prevented a ticket, but that's very negative customer sentiment, right? So that's actually a bad thing. So to offset that as a possibility, we added that explicit button, which customers can click on to indicate to us that the problem was actually solved. Not every customer clicks on this button, but a significant number of customers do, and that gives us more confidence that a good portion of those that quit the page are also satisfied with their answer. And another way that we try to validate this is by manually reviewing some of the conversations, which, by the way, we also strip out of private information. But that obviously doesn't scale as well. Hence, we kind of combine these two success metrics to give us enough confidence that the model is actually generally returning useful answers. Now, I've talked about things that went well so far. However, let's talk about something that we misjudged a little bit. So one of the features that we wanted to include here was for the conversation to be included in the tickets if a ticket was created after a Copilot interaction. So basically, if Copilot was unable to resolve the user's problem, then a ticket would be created and the conversation would be included as well. And the idea behind that would be that a support engineer would be able to review the conversation, see what troubleshooting steps the user already applied with Copilot, and potentially save a couple of back and forths, right? And that would potentially result in faster ticket resolution time. However, in practice, ticket resolution time has a lot of unknown variables. So it's really difficult to properly measure whether our feature has any positive impact on it. So we mention it as a nice bonus, but this is not a success metric because we cannot consistently rely on it to tell a story about how well the feature is performing, right? So we got those success metrics and they were pretty satisfactory for what we were expecting. And this means that we kind of want to carry on keeping those success metrics stagnant because they were already something that we were happy with while onboarding a new, more challenging customer segment. So that's what we're going to be doing now, right? We're going to be moving into the beta and we want to release that around November of 2023. Now we have kind of a similar question as last time. How do we safely onboard more customers? This time we're including GitHub Enterprise Server customers. And GitHub Enterprise Server customers, they host their own instance of GitHub, for example, on their own server. This means that they can have some more challenging support scenarios that have to do with their instance using too much memory, right? And sometimes the resolution to these problems is running a potentially dangerous command. So this is one scenario that's quite common that we really had to cover for, because this Copilot model can also, of course, return commands and other things that you can run in your terminal, which could solve a problem, but could also lead to irreversible effects. And it's going to be a really difficult situation if Copilot just returns a command and a customer runs that command, and that would lead to them breaking their GitHub server instance. That's a really big problem. So we ran another red team test with the same set of support engineers, this time focusing on trying to get commands outputted from the model and talking about riskier server topics, like what I was talking about before, right? So things like, hey, I have a memory leak. How can I investigate and solve this? Here too, we had remediations, and I just want to talk about the main remediation here, which is command scanning. If you've played around with Bing's GPT system, you might recognize this. So Bing GPT continuously scans the output of the model, and if it notices that the output is inappropriate, it will, for example, stop rendering the output and tell you, I'm sorry, I can't talk about that, or it will even tell you to stop talking about whatever topic you're trying to provoke it with, right? So similarly, our model is also being continuously scanned by just a piece of code that's scanning the output and checking if certain block listed commands are present in the output. Now, in our case, we do actually return the full output on the bottom here, but the most important part is if you recognize that one of these commands is returned, we actually add this warning. So here too, you see that if the customer is uncertain about the command's outcomes, they should just create a support ticket. Like, we don't mind customers creating support tickets when they need to. So this is a very important warning to make sure that customers are aware which commands can be potentially dangerous. In fact, some commands we don't even recommend you to run yourself. We only recommend you to run them after you've had contact with support, but these are very specific scenarios, right? In any case, you can see that here, once again, we had a really big focus on making sure that the solution was safe to roll out to this next customer segment. So now we're basically at where we are today. We rolled out to a set of customers in August and then again in November. We took some time for holidays and festivities, I suppose. And now we want to go to GA, which stands for General Availability. also known as releasing to all customers. What that means for us is releasing the solution to all customer segments, so free, team, and pro customers. Now, a lot of large language model solutions would just go ahead and do that, right? They would just enable the solution for everyone. However, for us, it's really important to answer the question, how we guarantee responsible AI. Now, to be honest, there's a lot of people that talk about responsible AI in theory, and they talk about how important it is that models are safe, and they are advocates of that, and I appreciate that, but I do think a lot of it is theory. So today I want to talk you through how we're actually doing this in practice, right? So this is actually going to be a bit of the talk where I walk you through the real pipeline that we're using to test whether the model can be considered responsible AI. So how we effectively are doing this is we're simulating over 1,000 conversations for harm. First of all, what does harm mean? Harm can mean wrong output in the intended context of the model. However, most of these scenarios actually consider users that are trying to abuse the model, getting the model to return sexually explicit content, discriminatory content, or something similar like that. And this happens a lot, of course, in ChatGPT, in Bing GPT, and we cannot exclude this possibility, especially not by including free customers, right? I mean, customers can do pretty surprising things sometimes. So we need to make sure that we actually check whether our model will handle these kinds of abuse scenarios properly. So this is a pretty big pipeline. And if you cannot see it in the back, no problem, I'll walk you through it. This is a pipeline that we're running in Azure Machine Learning, which is Microsoft's cloud platform to develop machine learning models. However, in this case, we're using it to evaluate a machine learning model, specifically our large language model. And this pipeline is based on a framework that's described in this paper. So for the researchers under us, I can send you a full link later, or you can take a picture. It's a paper by Microsoft that describes how you can measure generative AI applications for responsible AI harms. So that paper goes into quite a lot of detail. However, I want to provide most of the important details to you today by walking you through how the pipeline works from top to bottom. Now, there's three main elements to this pipeline. First of all, we have a task simulator. And this task simulator is responsible for creating conversation starters. So a conversation starter could be just a sentence or two, and the conversation starter makes use of a specific abuse persona. And this persona template could be something like, you need to act as John, and you are trying to hack into the large language model to get it to reveal its system prompt. Or your name is Sally, and you're trying to get the large language model to return, a sexual novel. I mean, this stuff actually happens, right? So these persona templates are being used by a different large language model, not the one you're trying to test, but just a vanilla GPT model, to generate those conversation starters. So then you have those conversation starters that act like a real person, and you can, of course, query those sentences against the large language model that you're trying to test. So we take that conversation starter generated by a different LLM, and we query that against the Copilot system in this case that we're trying to test. And then you get a response from the Copilot message. And you've probably seen responses before like, I'm a large language model trained by OpenAI, I cannot answer this, et cetera, et cetera. In our case, if one of the moderation policies is flagged, we return a more generic error. But the point is we do always return something from the model, right? So in the end, you get conversations, which are the conversation starters that were generated by the large language model together with the answers from our Copilot system. These conversations, they get formatted into a nice output data set. And then the exciting part happens. The conversations, they get sent to different annotation pipelines. And each annotation pipeline is responsible for judging the conversation on different kinds of harm. In this case, we have violence, we have hate and fairness, we even have self-harm and sexual scenarios, which hopefully gives you a bit of a sense of how serious we're tackling this, because it's not necessarily going to be an everyday scenario, but we want to make sure that the model doesn't output anything strange when users do try to provoke it to return this kind of content. Now, the annotation pipeline is yet another large language model, could be GPT-4, right? That takes that conversation and annotates it based on an annotation template. And this annotation template contains instructions for how to annotate a given conversation on these different types of harm. And the annotation could be binary, so it could be a 0 or a 1. It can also be a range of severity. It depends a little bit. What's even cooler is that the output can even be a reasoning as to why the annotation was applied. Because you're asking GPT-4, for example, to annotate these conversations, you can also ask it to explain its reasoning, and you will get an answer there. Now, of course, there's a lot of theoretical discussion going on whether this reasoning is true reasoning. However, it's nice that this is a possibility, right? In our case, we mainly rely on those metrics to see how many conversations were flagged as abuse. Now, how did we fare? Well, actually, we didn't trigger too many abuse scenarios. However, we did trigger abuse in a couple of places. Why is that the case? We didn't actually return any sexual content, for example. This is true. However, we actually realized that our error code that we return to our user is quite generic. So Copilot, for example, tells the end user, sorry, I can't help you with that topic. In principle, that works, right? However, this pipeline is quite strict, and it actually sometimes penalizes you if the model doesn't explicitly tell the user to change their tone of voice or not talk about this kind of subject. So instead of just responding with, I can't talk about that, it's actually sometimes required that the model says something like, please refrain from talking about this with me, or hey, even in the case of self-harm, it could even be something like, you can consider seeking professional help, although that's quite difficult to get right, So in general, I would say that the idea is that you at the very least kindly ask the user to refrain from talking about whatever topic is inappropriate. And so that's what, we're kind of thinking about improving. Otherwise, we didn't do too bad. And this is because we're using Azure OpenAI, which already has a couple of content moderation filters. And so some people might find it a bit excessive, considering we didn't fine tune or retrain the underlying GPT model, because effectively Microsoft has also validated the models that are running on Azure OpenAI, right? Sure, but it's still good to just do this validation, especially when you're pushing this model to production. And this is just how you actually execute on the promise of responsible AI in practice. It's a lot of effort, but it's quite cool, and I think it's worth it in the end. So the main takeaways from this talk, honestly, if you want, you can forget about most things. However, I would really like you to take away these 4 points. First of all, high quality data is crucial. As I said before, we already had this high quality data available. And for us, our well-maintained GitHub documentation made the solution work. It's verified and safe data, unlike previous support tickets and the community forum. That being said, we are trying to explore including those different documentation sets as well, but we clearly need to consider what it means to include those other data sources, right? So it just takes time to do right. Next, this is Copilot, not Autopilot. It requires up-to-date data sets to work properly and continuous testing with the support engineers. If we make major changes to this model, we will consider doing another red team test, right? Just to validate that what we're doing is always correct. Plus, if you test with, in this case, support engineers, it creates mutual respect. One worry that people perhaps rightfully so have is that these models are used to replace jobs. Once again, it's not the case here. We are not able to solve really complex support topics automatically using this model. It's just not going to happen. But that's not a bad thing. It means that we can focus on the simpler topics and still make sure that the support engineers can focus on what they do best. And by involving them in the testing process, they actually trust that you're doing this. And so it creates mutual respect instead of just ignoring them or not involving them at all. So we think this cross-team collaboration is very important. Third, we want to make sure that this is a customer-centric solution. So once again, we really respect the customer when attempting to instantly solve the problem. I'm probably just like you. I've seen plenty of frustrating support experiences. So of course, you can opt out of the solution and just create a ticket whenever you want to. That being said, if you still have any doubts about why we have to do this, at the beginning of the presentation, I showed you that there are hundreds of support tickets being created every day. It's a real pressing issue for us. So we still really want to automate things where possible. And to be fair, if we're able to instantly solve your problem and our answer is correct in that sense, that also helps you, right? Because it saves you time. So of course, this innovation comes with hurdles, but it's going to be worth it in the longer term. Lastly, and I think that especially GitHub and by extent Microsoft are really doing this well, is that we adhere to a lot of responsible AI practices. So you saw that we're running this extensive pipeline, which is also quite costly to run, by the way. And so this pipeline guarantees that the model is ready for production. And by the way, we are not able to even publish the model to production unless we run these kinds of pipelines. So they really are important to the general AI strategy. And this means that we limit the risk for both the customer and GitHub as well as a company, which is quite important, right? So that being said, I'd like to thank you. We have a lot of time for question and answers, I think, but if you don't get your question in, you can always connect with me on LinkedIn and ask your question asynchronously. That's also the way that we work at GitHub. We of course have meetings where necessary, but we like to chat asynchronously as well. So you can always connect with me and we'll see each other there. But for now, thanks, and that's it. Yeah, Steve, I think you were quite quick with your hand, so go ahead.
You mentioned during the alpha stage that if someone asks a question, it's related to terms of service, that you first inject a relevant part of the terms of service. How do you determine what is relevant?
Well, there comes Julia's talk, right? So, we actually have embeddings of all of this data, and then we're using vector search to find the most relevant bits of documentation. So, it's a nice combination of talks there because that's the theory that she proposed, and that's what we're using in practice. So we're using vector search to find the most relevant documents. Yeah.
I thought it was a really interesting discussion of how you actually put something into production. And it felt like you probably built most of the solution like within the first month or two of working on it. And then you spent a lot of time kind of limiting it and putting in safeguards. With some of the things that you mentioned, for example, not talking about billing or like the server command review, it seems like there's still like a non-zero probability that those things can slip through, right? Anything here, there's always that like factor. Did you get any resistance from like business stakeholders from that? And how did you overcome that?
Yeah, it's a good point. So actually one of the ways that we increased confidence in the solution from the business stakeholder side of things is by actually giving these kinds of presentations to them as well, to assure them about what we're doing. And in GitHub, because we communicate asynchronously, we post a lot of content within GitHub itself, and everyone is free to read that. So just last week, actually, because we are preparing for the general availability release, we published some details about the solution, and we got into a bit of a miscommunication because one engineer thought that we were directly calling OpenAI, which is not necessarily an approved vendor. And then we immediately, made sure that they understood that we're using Azure OpenAI instead, which isn't approved. And this is an example of how our open communication leads to everyone being able to judge the solution, but also us just communicating what we've done. And this means that we just do our due diligence, right? And just this open communication, continuous demoing of the presentation helps a lot. On the customer side of things, because it's an AI solution, we will always have some warning in place that results could be inaccurate. We are doing our best, but we also do rely a little bit on customers to be careful with these kinds of topics, right? So, there's that.
Thank you.
I thought you mentioned building this into Zendesk, is that correct?
Yeah, that was our initial brainstorm, is thinking of building a Copilot system inside of Zendesk. So we didn't actually continue with that because we couldn't measure the success, but that was the initial brainstorm idea. Yeah.
Because for the ticketing, you do use Zendesk.
Yeah, that's the ticketing
and you
system,
have
essentially.
presumably also the knowledge base in their platform.
Right.
So now you're building a customer service solution. Shouldn't it be Zendesk's job?
Yeah, it's a good question. So I think one reason why we have the support portal, which is custom built, it's not like we're taking a vendor's portal and just giving it a white label, is because there's a lot of complex scenarios for GitHub where the resolution doesn't rely on a knowledge-based answer, but it requires some kind of process to happen in the GitHub platform. So to give you a concrete example, sometimes it can happen that you delete a commit from GitHub, but the code, or at least the commit reference, is still somewhere in a repository. This is called a dangling commit. And to remove a dangling commit, you can go to the support portal and execute the dangling commit virtual assistant flow. But to resolve that problem, we actually need to do something in our backend, right? So we need to create these kinds of sophisticated solutions because most of the issues on the GitHub platform, I would say, are backend related. Well, I don't have the statistics, but that's my intuition there. Yeah, so that would be the answer. I think you had a question as well, right?
Yeah, I'm curious to know like what is the improvement to business metrics so far? Because you said it was a focus.
It's a good question. And for me, the difficult part about this talk was really thinking about, okay, how much do I want to share in terms of numbers concretely?
Yeah.
It's just been a bit difficult. I think I already knew this question was going to come, and I'll really keep it in the back of my head. I think what would be the best thing to do would be to later on, for example, publish a blog post about this, similarly to how, you know, Copilot first didn't have any success metrics open to the public, but later, you know, blog posts were released detailing that. I think to make sure that everyone's happy on the GitHub side, you know, I don't want to reveal those numbers now, but yeah, I understand why you want concrete numbers. Unfortunately, I have to disappoint you. I can just say that, yeah, it's satisfactory on our end. Yeah.
Okay.
There maybe was a question on that side still? Oh, yeah.
Since you were mentioning you are using OpenAI,
Yes.
it's expensive for a lot of organizations to use it in the R&D phase. So if you didn't have it, how would you vectorize your support pages? Which kind of Hugging Face model?
Yeah, it's a good question. So in this case, of course, we're privileged to have the Microsoft collaboration, so we can just use whatever we want. And I think Julia already indeed mentioned Hugging Face is a great place to both get your embeddings, but even large language models have open source variants, right? So off the top of my head, I wouldn't be able to give you a combination of, oh, you know, we would have used this embeddings model and this open source large language model, but it is possible to do in practice. And so I think that there's a lot of solutions out there that build off of an open source large language model, right? But yeah, I can't give you a direct answer because for us, that wasn't really something to consider because we have access to Azure whenever we want to. Any other questions? Oh, I think suddenly 3, so go ahead.
Well, you guys also have Copilot for automation for code and that kind of stuff. Did you focus only on the support engine? Are they split up in theory, or do you combine all?
Good question. So in this case, because we're technically sitting outside the product team, this is a separate microservice that's running completely separately from Copilot. But of course, in the longer term, we need to have a good strategy and standardization, right? So we'll likely have a really big Copilot platform where everything is shared. However, what will remain the same is that we use a different model because Copilot for code completions is based on Codex, and it's really heavily trained to give you back code completion responses. And so it doesn't really work that well for these support cases. But we will introduce more standardization in the future. That's for sure. There was a question around that side, but yes.
Yeah, the business use case for the Copilot is very interesting. As a GitHub user, I always, if I go to issues to create an issue, for example, for an open source project, or it's very difficult to find if the issue exists. So maybe before creating an issue, you could also have this kind of chat.
Yeah, I'm not going to say too much about that, but
did you think about did you think about this business case?
Yeah. I mean, yeah, as I already like teased a bit with the pull request stuff, Copilot-like systems are more and more in the actual GitHub platform. So yeah, keep your eye out on that.
Okay,
Sure.
interesting.
Yeah.
Actually, I think as long as you let the customer to switch from their coder screen into the support screen, it's really a big step for the customer actually. So me, my maybe be trivial, but it would be better if you can somehow integrate your Copilot support already into their IDE or something, so that they don't need to switch from one screen to another one.
Right.
That would be a big step to really let them dive into their role, and you just stay next to them quietly, and so that when they stop or something, you can sense it somehow. Then you pop up, hey, are you getting an issue which I may help you? That'll be.
I think this is an interesting proposal, and maybe I can go into that a little bit as to why it's difficult now, but might become easier in the future. So when we're talking about Copilot in your code editor, Of course, with any large language model, there's a given context window you can work with, a given limitation as to how many words you can insert. And in the case of Copilot for Code, a lot of that context window is taken up by the code window you have open and related files. And to make the code chat work properly, a lot of context is necessary to inject there, which means that we probably don't have a lot of room to inject the most relevant documentation and site policy. However, you're making a good point. We can also see if the questions that the customer is asking relates to the GitHub platform more so than it does to code. And I think that this will become easier to do in the future. However, for Copilot in your code editor, the focus right now is actually to make sure that customers ask program-related questions. And that is already something that's quite difficult to do because it's really difficult to determine that scope, right? So for example, if you ask our model and the Copilot model in VS Code to create a chicken sandwich recipe, it might deny that request. But then if you wrap that in some kind of statement like, oh, I want to create a Python method that returns a chicken sandwich recipe, then it might listen to you. And that should give you a good example of how it can be quite difficult to detect the intent of the user. So whether they actually have a question about the GitHub platform. But I do think that as we move on with the years, it will be easier to do this. And then, yeah, we can have an integration like this. Yeah. Well, I think both of you.
Is there any plan to transfer some kind of information between interaction sessions in order to generate more customer-specific answers?
Yeah, so I think for our situation, the most important thing would be to inject more customer context that we can fetch from our backend. There are other Copilot scenarios where maybe, it's more interesting to inject, for example, the last repositories that the user visited, right? And we can also play around with that. So indeed, including more user context is quite important, especially because that's effectively what support engineers often have to do. They see that a customer has a problem and they first need to investigate, hey, what plan does this user have? What did they recently do? Maybe, what IP address did they last log in as? So some of that context that's not as sensitive, we might actually want to include in the model for a future version. So yeah, it's a good suggestion indeed. I think there's this question there.
Yeah, so you're trying to answer the easy questions,
right?
And the model fetches the information from various places. Is there also a feedback loop to the ones that are creating the documentation to say, this very easy question is asked a lot, apparently the documentation isn't so.
Great question. So we actually do have this feedback loop, and that's one of the roles of our product manager. I also want to, give a shout out to the rest of the team because it's obviously not just me. And one of our product managers is really responsible for having that communication with the documentation team. Similarly for our project manager as well, program manager. And this does happen every now and then. However, sometimes it's difficult to answer a specific question in one document article. Sometimes it requires multiple articles to answer a question. And in that case, it's a little bit difficult to recommend the docs team, hey, you should edit this specific article, right? Now, one suggestion could be move the Copilot solution into the doc site. But the only problem with that is that the success metrics become more difficult to define because, what are you going to look for? People giving thumbs up on the messages? Yeah, that might have helped them, but it's much less difficult to recognize whether it actually solved their problem compared to having it to experience in a support portal. So yeah, there's multiple choices to be made there.
Given the scale of GitHub as a company, did you, in the development of this feature, run into any rate limits with these Azure OpenAI services? For example, if 300 customers hit that button at exactly the same time, how did you think about that?
Right, so the support portal is not that crazy, luckily, so that helps. But we did do a phased rollout on purpose for that reason, and especially at the beginning, there was a lot of rate limits around GPT-4 specifically. So we prevented that by rolling out customer slowly, right? So that's how we did it. We just rolled out slowly, and then you kind of know what the expected load is. Yeah. I think there was a question there first, maybe around there. No. Oh well, yes.
Question about your confetti button.
Right.
Looks incredibly cheesy, but I love it. Are you at liberty to put some numbers on it? Like, what was the percentage of queries successfully answered by Copilot?
Yeah, so I can say one thing that I will say, because I think it's an interesting detail, is that the amount of customers that click on the My Problem is Solved button is under 2 digits in terms of percentage, but that's still fine because most customers, they don't really bother to give us that feedback. It's enough percentage that we are confident that, okay, a lot of the users that just quit the page, they do have a satisfactory answer there. So it's not something like 50% of users press that button, because honestly, most customers that get an answer, they will just be happy and then they quit the page. So
Yeah, but it's a large volume, so it's a lot of save time, right?
yeah, exactly. And it's difficult to, I'm not going to express that in dollars or anything like that, but yeah, that is something that you can do in the end, right? Because, it saves time for both the customer, but also for us because we've, technically prevented the support tickets and you can average that out, to see how expensive one support ticket is, of course.
And just a quick follow-up question about the quality of data.
Yeah.
You mentioned that you kept to the official documentation. Did you actually do a test with forum responses and ticket material and figure out that it doesn't got it? Or is that just something that you felt and you're keeping it for future?
Yeah, we're keeping it for the future because in theory, it gave us a lot of problems. So the personal information from the support tickets, we can try and create a PII filter and we might attempt that. But honestly, I feel like we need to do more due diligence to understand what data could be leaked potentially. And for the community's data, well, because we're working with this kind of data a lot, we intuitively know, not all the answers are great. So we just didn't want to implement it for this first version because it wasn't necessary to achieve that first business success. Because what we can do now is have a look at the questions that were not answered properly and first understand, okay, why are they not answered properly? Is it because we're missing that kind of data, or is it something else? Are we missing the context of the customer? So we can investigate that first and then continue from there.
Excellent, thanks.
It was up
Yeah,
to
I had a question about the tone of voice. Did you tweak that according to make it more consistent with your engineers? Because that's an interesting.
Well, actually, we actually steered it together with some of the support engineers because we actually have a handbook that describes how you should act towards the customer as a support engineer. It's actually quite difficult to steer this because, for example, the model shouldn't be very apologetic, but we still see that the model can be quite apologetic sometimes. This is a good use case for fine tuning because there you can give a bunch of examples of question answer pairs where the model will learn the tone of voice, right?
Yeah.
So I think if we want to properly fix that, we would need to fine tune the model instead of just saying in a prompt that it should adhere to, these tone of voice rules, because that works in most cases, but it's not really bulletproof. But for now, that wasn't the highest priority.
No.
It is a good point though, because we do have a tone of voice for support engineers. Yeah, it is quite important.
Why are you relying on this confetti button and why are you not looking at follow-up actions the user takes?
Yeah, that's an interesting one, and I actually got the same question from the product manager as well a couple of times. Well, it depends a bit on how easy it is to track the customer actions, because the support portal is a different part of the GitHub platform, right? So, okay, theoretically, we can track what they do on the GitHub portal, on the GitHub site, the actual platform, to see if they, for example, actually did the action that fixed the issue that we described on the support portal. And, I'd love to execute on this. It's just difficult to know where to start because there's so many different support cases. I can give you one example of where we did this recently for something that we can actually fix. So there's also a flow for users that are unable to sign in. And there we do ask what your username and your email address is. And for that specific case, we actually do end up checking later on if that user did end up logging in. So that's one concrete example where it's pretty easy to do it, but there's a lot of cases where tracking that is quite difficult, right? But I'm not saying it's impossible. So it's an ambitious goal. We should probably follow up
one
on.
of the things it's quite good, but some things I don't find too intuitive in GitHub, so I keep looking for it again and again.
Yeah.
Track that. I think you can use that information to. You should be able to follow up what users are doing before they go to your portal or what they do.
Yeah. And so I think it's a good point, maybe to give you a bit more information as to where we're at with that kind of data collection and data science related stuff. We do try and look at trends in the ticket data. So to understand if suddenly there's a spike in issues related to GitHub Actions, to understand, hey, maybe there's a product issue, right? Maybe some new feature got released and it's unclear in the UI. But of course, the holy grail there is to actually look in the platform itself. So yeah, that's true. Yeah. Oh, yeah.
Yeah, one more question. What do you think? Which team is required, like, to do similar integration? Keeping in mind that you don't retrain, fine tune the model, like.
So you mean in terms of the engineers and
Yeah, like.
Right. So I think the most important thing is that you need a team that's willing to learn and to be open-minded. So for example, I did a lot of pet projects with the GPT API, so I was able to teach other engineers about that. However, I was less aware of the business context, so I relied on the program manager to tell me about, what problems GitHub is facing. So if you have a team that's willing to learn and be open-minded, I think that's important. However, I would also say that you need a team that's ambitious, but also realistic, because a lot of the times businesses have nice ambitions with large language models, but these ambitions go a bit too far in the sense that it's probably not going to be feasible at this moment. Once again, it doesn't mean you can't be ambitious, right? Definitely set those longer term goals, but try to work towards an actual sensible solution that you can build, because this is technically by far not one of the most complex LLM projects that I've seen, but you can see that it took almost a year to get fully into production. So it's not easy to do it right. So yeah.
How many people are you in the team?
It's an interesting question because the team is about, I think, like 18. That's not that yet. It's about 18 engineers, but they're not all working on this. So maybe it's fun to talk about this for a bit. So the way that GitHub works in our team, at least, is that our team is split up into squads, and each squad is working on something else. So we have the support squad that's really busy with the support portal. We have a success squad that's more related to figuring out how to increase customer success. We have an intelligence engine squad that's working on a lot of data science-esque projects. When it comes to this team, it varied a little bit throughout the stages. I would say the average team count is about 4 people, and that includes the project manager and the program manager as well, so not just the engineers. So keep it simple, right? It's the pizza principle. Don't have a bigger team than you can share a pizza with. So exactly. So that's what I would also recommend. It depends on the scope of the project. Sometimes you do need a bunch of people, and if you don't have that high quality data, maybe you need like 3 data scientists or 3 data engineers just to get the data you need, right? So we were quite lucky there, and we could also kind of rent the time from the support engineers for the testing as well. So it's a bigger team from that perspective.
Have you been using the existing ticket database to train the system or to get answers?
Yeah, so that's what I mentioned before. We did think about that, but we ran into personal information issues there. And once again, we haven't validated yet that the questions that couldn't be answered by the model were due to a lack of training on those support tickets, right? This could be the case, but this is something that we have to validate after we move the current solution to general availability. So, maybe in the future. But we do want to do this with respect as well, because there's a lot of platforms that will just use your data without telling you. And of course, this is a difficult topic because you need data to train these models or to at least fine tune them. But at the same time, you should at least make your customers aware of that, right? And some customers are really not comfortable with us using their support data to probably fine tune a model. So we just have to think about it more. Julia's coming in to stop.
You can ask more questions with the hot pizza that just arrived.
Hi, this is Julia from the Amsterdam Elastic community. If you like this recording, you can join our local meetup groups for in-person events around you, and hope to see you in our offices soon.